Okay. Example 2. Let's do x cubed plus 4x squared plus. I'll still guide you a little bit through it, and on the third one I'll leave you completely alone. So what I want you to find for me is, what is that list of potential roots?
5 or 6?
It's a 5. It's an ugly looking 5. Let me fix it. That's one of them, but there's more. Because remember, you have plus minus of every number.
Obviously.
Well, find me the list. Yeah, the pass is hanging on my lap. And 100% look at the notes. You're just barely learning. Think about, look how I found P, look how I found Q. And I'll do a shorter version this time of this. Okay, here we go, guys. Let's see. So this is P, okay? P, the only ones that you have is 1 and 2. Okay, Q is just 1, so the only number you have is 1. Okay, so the list is all those numbers above 1, right? So it's 1 over 1 and 2 over 1, which is just the same numbers. So you have 1, negative 1, 2, negative 2. I skipped all that middle part. Okay, let me not skip that part because I see you confused. You're dividing all those by 1. Right? Anything divided by 1 is a... It does, but it'll turn out to be the same at the end, because if you do like 1 divided by negative 1, you'll get positive 1. Yeah. So it's just 1, negative 1, 2, negative 2. Is that okay? Or no? Someone? So let me, I feel like you guys kind of lost you on there. Do you agree that P is positive 1, negative 1? Positive 2, negative 2, right? And then all those you're dividing by positive 1 and negative 1, right? So let me divide those by positive 1. And let me, different color, divide them by negative 1. Maybe this will help you. So 1, negative 1, 2, negative 2. But these ones I'm going to divide by negative 1, okay? It's the same thing, watch. Check this out. So positive divided by positive, positive. Negative divided by positive, negative. Positive divided by positive, positive. Negative divided by positive, negative. Okay, let's do these ones different color. Positive divided by a negative. Negative, negative divided by a negative. Positive, negative. Running out of air over here, but you guys get it, right? Notice it's the same numbers. Yeah? So once you see it once, you see that it doesn't matter. It's at the end of the day, it's these. Is that okay? Okay. That way you don't have to do that every time. Okay, so my list, guys, my potential list is 1, negative 1, 2, negative 2. That's the important part. Okay. In my equation, it ended with a 2, right? Yeah. x plus 2. Okay, go ahead and synthetically divide that. I suggest that you start with 1 because it's usually easier to work with.
It has to be negative.
What does?
The list, one of the, when we're multiplying by, it has to be negative.
Why?
Because if not, you'll just keep adding that and your factor will be 0.
Oh, okay.
So it has to be either negative or negative.
Good. So if you made that connection, try.
Do you keep going until you get 0?
Yes. You gotta keep going until you get one root. Once you find one root, then you can shortcut after that. But you need to find one. Does that mean 1 doesn't work? Right? Lincoln saw that ahead of time. Let me show you. 1, 4, 5, 2. 1 times 1 is 1. 4 plus 1 is 5. 1 times 5 is 5. 5 plus 5 is 10. It doesn't work. 1 times 10 is 10. I just wanted to show those that. Well, we need a 0 there. Okay. So this one, no bueno. No good. You need a 0. Okay. So you try the next one. Try negative 1. Does work? Okay. Try it, make sure. 1, negative 1, 3, negative 3, 2, negative 2, 0. Okay. So it looks like negative 1 does work. Very frustrating for you if you mess up adding something wrong or something, because it messes all this up and it's a lot of work. So be very careful, surgical about your work. So there's a root. Okay. You have options. You could test 2 and negative 2. You could do that. Okay. Or, well, I already know this one. I can try to factor this, which is what I would do because they're usually easy to do. Now, if I got stuck factoring, then I'll go try to synthetic divide. Okay. But look how easy this one is. What times what is 2, but adds to 3?
2 and 1.
2 and 1. Plus plus. Because those are plus plus. Okay. So I have another double root and a negative 2. Double root right there, because it's the same. It's the same twice.
Oh, is that why we get the 2 degree?
Uh-huh.
Oh, okay.
Because they're happening
Yeah,
twice.
twice.
So from a factor, it probably came from here at some point.
Yeah.
Yeah, or
okay.
plus 1, yeah. Okay, so let's sketch this. Negative 1 and negative 2. Should have done it more over here. What's our y-intercept on this one?
It was 2.
3, 2.
2.
2. So we have a 2. Okay, so it's a positive odd function. So double bounce. That's what a double root is. It bounces on it. Okay, guys, so I kind of walked you through that one a little bit, but any questions right now that are bugging you? So when it doesn't work, try the next one. Okay. If you don't like factoring, keep on trying the other ones. Okay. Okay, let me give you one, and I'm gonna set 3 minutes this time. That way you have enough time and the whole thing. Okay. Sample 3. Okay, we'll do 3 minutes on this one. The end result is that you sketch the graph with the accurate x-intercepts, y-intercept, the whole thing. Oops.
Wait, so the last one, the y is 2, right?
I think so. Yeah, Lee, I put it there because I forget to. I'll forget what order it's in. Sorry. Huh? She went as soon as she gets back. But will you put the food up though? Thank you. She's back. You can go now. You were absent yesterday, weren't you? No? Okay, I thought you were. I don't know who's absent yesterday. Who was absent yesterday? Anybody in this class was absent? Okay, good. I'm going to put the list of factors up here quietly. That way, if you're having trouble, you can get unstuck and keep on moving, okay?
So,
Bless you.
So with this cut,
I don't know yet until you keep going.
I don't know where to go.
But right here, try to factor that. Because you already have one root.
Oh, by the,
No,
Look.
but that's not.
Remember, you can write this as an equation.
Have you seen it?
so that would be x,
Minus
yeah, minus
2x.
x plus 2, all that.
Oh, yeah, yeah.
Okay.
But write it first like x squared minus 2x. Yeah. ¿Entiendes? Ok. De ahí sigue la división sintética. Pero empieza con el 1. Se divide por 1.
I think I did it first.
Good.
I had this double root and then this 11.
I don't remember, but usually if it doesn't, like if you mess up, it turns super nasty. So if you're getting to like actual root, then you probably did it right.
I gotta graph it, right?
Yeah. Okay, guys, I'm not gonna belittle this. It is pretty heavy, okay, because you're having to use a lot of your. It's not just one flavor of thing. You know, you're factoring and all this other stuff. So these are challenging problems, okay. So be nice to yourself. Don't get frustrated. Okay, I'm gonna start with the 1. I'm gonna test the 1 out. Anybody have trouble finding those, by the way? Okay, I'm gonna test the 1 first. So 1, negative 13, 23, negative 11. 1 times 1 is 1, that adds to negative 12, that multiplies to negative 12, and that adds to, what is that, guys? 11, positive 11, 0. So we have a root, okay, at x equals 1. Not always it's going to be the first one, okay? Sometimes you got to go a few down. But we have one root here at x equals 1. From here, again, I just want to reiterate, you could just keep on dividing. Try negative 1, try 11, try negative 11. Or you could factor this. Now, I'm going to be frank with you, okay? I had to look for an hour for problems that you get here and you factor. Those are really special, nice problems. Sometimes they don't do that. Okay, you get here and it's this nasty problem where you have to use the quadratic formula or do other stuff. So we left that for another year. Okay, we just keep it basic right now. Negative 1, negative 11. So your root is at 1, double root, and at 11. Okay. And this was a positive odd function, right, if I recall. So it's going to look like this. And you know, I'm not stressing end behavior and all that, but you guys, all that will come together, okay, whole package. 1 and 11. What's my y-intercept on this one? Negative 11?
Yeah, it's odd.
Okay, so let's see if we can fit this shape to this. Okay, we have a double root at 1, so wait, I'm messing up. Oh yeah. Bounce on it, because it's a double root. Double root.
Oh, you go under.
What happens at double roots? Bounce, trampoline.
I was like, what's it keep? Because I kept on going.
Double root bounce. What if it had been a triple root? What's an odd? Cut. Okay. How many of you had maybe not 100% success, but 80 or above success percentage-wise? Okay, good. You got most of it. Okay. Okay, I want to show you this other kind now. Okay. Any questions, though, guys? First, everything makes sense? Yes. Do you? You had a double root at 11? Okay, I'll go check your work, okay? Okay, guys, so this one, how could we call this one? I don't know if we're on that one, but this one's a little bit different, okay? So no, just leave it there. So, 2x cubed plus 9x squared plus 3x minus 4. So what's different, okay, and this brings it to a different category, a little bit harder, okay, not a lot, just a little bit, is that's not a 1. It's just like when you factor, you know when that was in a 1, it changes it a little bit. So let's think of these. This one is p, so plus, minus, 1, 2, and 4. Right, those are the numbers I can multiply to 4. For q, the numbers that multiply to 2 are 1 and 2. And that's it. Okay, so p over q will be just slightly different this time. P over q, still plus minus. All these numbers are plus minus. 1, 2, 4. But this time they're not just over 1, so it's not just the same number. They're over 1 and 2. Okay, so let's see what that means. Now, all the over 1s will still be the same number, right? Anything divided by 1 is still 1. So this list will be a little bit larger. You still have 1, negative 1. 2, negative 2. 4, negative 4. Those are the ones when you divide it by 1, which you get the same number when you divide by 1. You follow me there?
Yes.
Okay, now you have those numbers, but you're going to divide them by 2. So 1 divided by 2 is 1 divided by 2. Or 0.5 if you like fractions, or decimals better. Okay. What's 2 divided by 2? Do we already have 1 on this list? Yes, we don't need to repeat it. Okay. What's 4 divided by 2? Do we have 2 on this list? We don't need to repeat it. It's already there. Okay. So list a little longer. But remember, we don't have to test. Hopefully you get lucky in the beginning, and then we can extract the other roots faster. Okay. So let's try. I just like to start with 1. You can start with whatever. What was the problem? 2, 9, 3, negative 4. Start with 1. Is 1 a root? Whoever gets this first, let us know. No? Okay. No root. Okay, what about negative 1?
Oh my gosh, it worked.
Negative 1's a root? Okay, we have one person saying negative 1's a root. 1's not. Yeah, 1's not. But what about negative 1? Somebody else said negative 1 is. We have one person saying negative 1 is. 2 people.
I think we'll start working with negative 2, so it's going to be 1 that just adds. So we do.
I just want to get a little more confirmations.
It's not 4.
It is still doing? Yeah, okay. I'm going to do it, not because I don't trust you, but because I need these numbers on the bottom. Okay, so 2, negative 2, 7, negative 7, 4, negative 4, negative, positive, 0. Y'all are absolutely right. Okay, root. Now, here's where I hope this thing factors. 2x squared. I haven't done this problem, okay, because remember I told you I readjusted it for you guys? So we didn't get to this one. So let's try to factor this. Is there something that multiplies to negative 8, but adds to 7? 8 and 1. Positive, negative. Y'all agree with this? But a lot of people that missed this question on the test forgot to do, they did this. What's wrong?
You forgot to.
2, you got to put 2 and 2. And then 1 reduces, right? Okay. So factoring, but our roots are negative 4. I think that's faster than having to test all those numbers. Okay. What's that other root, guys? Okay, you have to move the negative 1 over to the other side so it becomes positive. And then how do you move this 2 over?
You divide by.
So you have a 1 divided by 2. Let me do it. So 2x minus 1, this is what you're really doing. So you add 1 to both sides. 1. Then you have to get rid of that 2, so that's multiplying, so you divide both sides by 2. There's all our roots. We're out of time though, okay? So hopefully you got the gist of that, okay? You're doing some heavy duty pre-calculus.